Okay, good afternoon, everybody. So I hope you can hear me. So for today, we'll continue our discussion of the remainder of Module 1. I was trying to check if everybody has already submitted um, homework 1 or was that homework 2? Basta yung huling homework because I would like to say a word or two about it. The last time I checked is parang may isa pang hindi na pag-submit, but I'll double check again later, and then probably I can say some words about it on Thursday. But if you have already checked your submission in Canvas, I already graded it and put some remarks on it. But I would like to stress some points about it, especially problems. Actually, for both problems because there are common errors um, that or some errors that had been used or had been committed by a number of you guys. So gusto ko lang i-clarify para sa problem set ay hindi nyo na maulit. Okay? But maybe I'll do that on Thursday. I'm still waiting for one submission. Okay. Para hindi na rin ako mag-upload ng answer key. Okay. So discuss na lang natin sa classes saka para immediate din yung feedback. Okay, so going back to what we did last time, so we are at the tail end of Unit 1. So here we'll be talking about, or we were talking about open and closed sets in R. So binalikan na natin, reconstruct natin yung set of real numbers. We talk about the axioms that separates the real numbers from other number sets like the order and then the completeness axioms. And then last time we started talking about topology on the set of real numbers. And crucial or fundamental to creating a topology on the set of real numbers is the concept of epsilon neighborhoods. And we said that an epsilon neighborhood is basically, at least on the set of real numbers, this is the set of all real numbers that are within epsilon distance from the number x. So if x is situated here, you want to see what the open ball center that x with radius epsilon is. So from x, you just measure epsilon units to the left and epsilon units to the right. And there you go. This would be your open ball or epsilon neighborhood around around the number x. So in the set of real numbers or in one dimension, this epsilon neighborhood is just the open interval x minus epsilon, x plus epsilon. And again, in analysis, when we use the variable epsilon, we usually look at its significance when epsilon becomes very, very close to zero. So yun yung imagine natin later when epsilon becomes very, very small. And then after we have defined what epsilon neighborhoods are, we discuss the concept of open sets. So we say a set A is open in R, okay, or is an open subset of the set of real numbers if for every element of X for every element of A, there always exists an epsilon neighborhood that is properly contained in A. So meaning for all X in A, there exists an epsilon greater than zero such that the open or the epsilon neighborhood centered at X is a proper subset of the set A. Meaning, open yung set. Ano ba? Ito yung set A ko. An example of an open set is the open intervals, and that's how they got their name, open intervals. So if I get any X on this open interval, say open interval little a to little b, pwede akong makapag-construct ng epsilon neighborhood that is still within the confines of the set A. So hindi siya lalabas dito. So I can pick this open interval. I can pick this or this epsilon neighborhood. So it doesn't matter how big or small that epsilon neighborhood is. The only requirement is the existence of an epsilon neighborhood that is properly contained for A. And if you can find some for all elements of the set A, then we say that the set A is open. Okay. Closed intervals are not open sets because if you have a closed interval, meaning the boundaries A and B are included in the set, I can pick the set A or the number A. It is an A, but the problem is if I choose any epsilon, however small, that epsilon neighborhood will not be properly contained in A. kahit liitan ko pa yung choice of epsilon, laging yung epsilon neighborhood around A ay magkakaroon ng mga elements na nasa labas ni A. That makes closed intervals not an open set. Okay? Kasi kailangan sa lahat ng element ng set, dapat makakakuha ka ng at least isang epsilon neighborhood na nandun sa loob ng set na yon. Okay? And I guess this was the highlight of our last discussion, of our discussion last time, when we proved, let me see, yeah, when we proved one important characteristic of open sets, or how to create open sets from smaller sets. Kasi ang classic example natin ng open sets ay yung mga open intervals. Now, if you want to construct other open intervals, we can do, number one, take the union of an arbitrary collection of open sets. So, mangolekta ka ng kahit ilang open sets. Pag kinuha mo yung union nila, open pa rin yung makukuha mo. Or if you have a finite collection of open sets, get their intersection, what you get is another open set. Okay? Now, it might be a good thing for you to think, bakit kaya may restriction yung theorem, yung part 2 ng theorem 12? You look at theorem 12, required na finite collection ng open sets. Doon lang natin nag-guarantee na yung intersection nila ay open. So can you think of a counterexample? A counterexample na hindi finite collection pero ng mga open sets tapos yung intersection niya ay hindi open. Probably that would be one problem in the upcoming problem set. So start thinking about that. What would be a counterexample to the statement the intersection of an arbitrary collection of open sets is open? Kasi kung makikita yun, yung union walang pasintabi. Kahit ilan ang laman ng collection or kahit ilan yung ipag-union ko, ang union nila ay open pa rin. Pero when it comes to intersection, restricted. Dapat finite yung number ng mga sets na ipag-union, pag-i-intersect ko para yung intersection ay maging open. So ano kaya yung problema kapag meron kang infinite collection tapos kinunan mo ng intersection, posible daw pala na magkaroon ka ng hindi open na set as their intersection. So kindly think about that. That's a nice problem. Perhaps I can include that in the upcoming problem set. Okay, now let's continue. And I guess we stop at definition 9. And definition 9 gives us a definition of what we call a limit point. So let's read the definition. A point X is a limit point of a set A if every epsilon neighborhood of X intersects the set X in some point, possibly other than X. All right. So let's look at the tiny details of this definition. Look at the restriction on X. It just say a point X is a limit point. So that says that X is not necessarily an element of the set A. So posibleng meron kang limit point ni set A pero yung limit point ay wala dun sa set A because there is no requirement that X is inside the set A. And then nagiging limit point siya kapag kahit anong epsilon neighborhood niya ay nag-i-intersect kay set A in some other point other than itself. Okay? Or basically in symbol, so X is a limit point if and only if for every epsilon greater than 0, there exists a C not equal to X such that Z is an element of this intersection. Okay. Itong intersection na to, dapat laging may laman na element other than X for any epsilon, however small it is. Okay. Now, the limit point is also called the accumulation point. It's also called an accumulation point or a cluster point. Bakit? Kasi graphically, nagiging limit point siya. Halimbawa, ito si set A. Usually, pagka real analysis, mas madali siyang maintindi if you look at kung i-interpret mo, lalagyan mo ng meaning yung mga terms kasi usually yung terms ay may dahilan kung bakit yun yung pangalan nila. And also if you couple it with illustrations, okay? So suppose this is my set A, say, okay, halimbawa, close interval AB. Kunwari, ito yung set A ko. Okay? Tapos, what it takes for an element of the set to be an accumulation point or a cluster point. So ba ito si element X. So magiging accumulation point si set X kung lahat ng epsilon neighborhood around X dapat nagko-contain siya ng elements ni A less the set containing X. Okay? So halimbawa, piliin ko tong epsilon neighborhood na to. Okay? Dapat yung epsilon neighborhood na to, from here till here should contain other elements of A aside from X itself. And then I should be able to do that for any epsilon. Okay? So syempre, kapag si epsilon ay napakalaki, mas malaki yung chance na yung intersection ng epsilon neighborhood na yun at saka ni A ay non-empty or magkaroon ng element aside from X. Okay? Pero kung paliitin mo ng paliitin yung epsilon, and then mag-zoom in tayo, dapat itong maliit na epsilon neighborhood na to, dapat mag-contain pa rin ng elements ni A aside from X. And if that happens for any choice of epsilon, however small, then that means X is a limit point or is a cluster point or is an accumulation point of the set A. So kaya siya accumulation point, ibig sabihin nag-accumulate sa kanya yung mga elements ni A or nagcluster around X yung mga elements ni A. Kasi kahit gaano kaliit yung epsilon neighborhood, lagi pa rin siya nagkakaroon ng elements ni A aside from itself. Okay? So pwede nyo siyang tandaan that way. So hindi ka nauubusan ng element na malapit kay element X. Kahit yung distance, yung threshold para sa distance ay paliitin mo ng paliitin. Okay? And again, that's why we call it an accumulation point. Kasi nga, sa kanya nag-accumulate yung mga elements ni A. Okay? So nandun pa sa remark 13 yung other names for the limit point. Okay? Now, before illustrating that, let's look at definition 10. In definition 10, we define an isolated point. Okay? So, but here, if you look at definition 10, it says a point A in the set capital A. So for it to be an isolated point of a set, that point or that number should belong to A itself first. Okay. So a point A in A is an isolated point of A if it is not a limit point. Okay. Madali siyang tandaan kasi intuitive yung meaning ng isolated. Ibig sabihin, hindi siya limit point, so hindi nagka-cluster around little a yung mga elements ni capital A. So, formally, ibig sabihin, there exists an epsilon greater than 0 such that the intersection of B epsilon of X of A with A, tapos tatanggalin mo yung set, yung element A from the intersection is empty. Ibig sabihin, yung intersection ng epsilon neighborhood, ng isang epsilon neighborhood, isang specific value for epsilon, and A ay wala ng ibang laman except kay little a. So, ibig sabihin, merong isang epsilon neighborhood na walang laman na ibang elements ni capital A. Kaya siya isolated. So, makakahanap ka ng maliit na neighborhood kung saan nagsosolo siya na element ni A. Alright? Okay. Let's consider some examples. So I hope that those illustrations helped. Okay. Saka madaling intindihin kasi pag tinatagalog or nililaymanize mo yung mga terms sa analysis then coupled with the drawing. So let's look at some technical examples here. Okay. Example 4. We consider this set. So this is our set A. Nakalimutan yatang i-define na ito ay si set A. Okay. So this is our set A, the set of all rational numbers of the form 1 over n, where n is a natural number. Okay, and then let us show that each point of A is isolated. Well, before you do a formal proof, because of course, magaling yung nagsulat nung problem nung lecture notes kasi alam niya na kagad ano yung pipiling epsilon. Remember, para mapakita na isolated point, kailangan bigyan mo ako ng epsilon. Na yung epsilon neighborhood na yon ay wala ng ibang laman na element ni A aside from the number itself, right? Pero usually madali siyang tingnan graphically. So, pwede nating i-plot ano yung mga elements ng set A. So, gawin ko siya dito. Ito yung real number line. And then we start with 1 here. That's an element of A. Siguro lagyan natin ng dot. And then susunod na element niya ay 1/2. Then third element niya ay 1/3. Then 1/4. Figure not to scale na lang para ma-drawing ko sila ng maayos. And then 1/5. And so on. Right? Now, para maging isolated point, yung mga elements ni capital A, dapat sa bawat isang element ni capital A, may maibigay ako na epsilon, na yung epsilon neighborhood na yon ay wala ng ibang lamang element ni capital A. Okay? So remember, ang capital A ko dito, lahat lang ng mga dotted points. So if you look at the first element, say 1, okay? So, kaya ko bang bumuo ng epsilon neighborhood around 1 na wala nang mahagip na ibang elements ni capital A? Of course, I can choose my epsilon to be, say, dismal. Para yung epsilon neighborhood na mabubuo ay ito lamang. Right? And obviously, wala siyang ibang elements ni A except for 1 itself. So that means 1 is not an accumulation point. Because I have found an epsilon neighborhood around 1. For instance, this guy, this epsilon neighborhood, that contains no other elements of capital A. Now, if I go to 1/2, pwede ko rin piliin ito as my epsilon neighborhood. Kasi siya lang yung nagsosolong element ni A dun sa epsilon neighborhood na yan. For 1/3, I can also find that. 1/4, yes, I can do that. Kay 1/5, lakihan pa natin. Yun, meron pa ring epsilon neighborhood. And actually, you can do this for all elements of capital A. So, ano yung suggestion nyo na ano? So, ngayon, at least kumbinsido na tayo graphically na talagang lahat ng elements niya ay isolated points. Okay. Now, but can you guys give me a candidate for the epsilon? If I am to write the formal proof, ano kaya in layman's term yung candidate para sa generic epsilon, para makapakita ko na yung 1/n is isolated? Okay, any thoughts? Oh, but first, am I making sense? Baka daldal pala ako ng daldal, but I'm not making any sense. Hello guys! So again, gusto nating ipakita na lahat ng 1/n ay isolated. Okay? And again, for 1/n to be isolated, we must give an epsilon such that that epsilon neighborhood, okay, doesn't contain any other element of the set A. So, halimbawa, kay 1, pwede kong gawing epsilon ay say, pwede kong gawing epsilon ay 1/4. Kasi if I go 1/4 unit to the left and 1/4 unit to the right, yung 1/4 neighborhood, okay, yung B sub 1/4 of 1. So B of 1/4, B of 1 sub 1/4. So the open ball or the open interval centered at 1 with radius 1/4 will not contain any other element of the set A. Kasi hindi niya mahagip si 1/2, si 1/3, si 1/4, si 1/5, and so on. Okay? So kay 1/2, sige, kay 1/2, ano kaya yung posibleng epsilon na ibigay ko? Or na pwede nating piliin? Anybody? Ano kaya to? Ano kaya yung pwede kong piliing epsilon na wala akong matatouch na ibang elements nung set A? Kahit hindi specific number, i-describe nyo lang ano dapat yung piliin kong epsilon. Or how can I compute or find that epsilon? Di pala compute. How can I determine? Kahit kwento nyo lang, guys. Kailangan ko kasi ng konting period para humigop ng kape. So kaya, okay, isip. Come on, guys. Sige, +1 sa problem set. Unang makakapagbigay ng method. Paano ko mahanap yung epsilon? Kasi di ba existence lang ng epsilon. Na yung epsilon neighborhood na yon ay walang ibang lamang elements ni capital A. So para kay 1/2, ano kaya yung epsilon na pwede kong gamitin? Or kung ayaw nyo magbigay ng specific value, bigyan nyo ako ng idea paano ma-compute yung epsilon. Oh yes, Carlo?
Sir, for 1/2, pwedeng 1/2 minus 1/3.
Pwedeng 1/2 minus...
So yung difference nung the next value. Difference nung value and the next value.
Okay, yeah, I get what you're saying. Pero be careful, yung kasunod dun sa... Ay, kaya lang yung set natin walang order. Pero I think what you meant is yung mas malapit na dot sa kanya.
Since yung neighborhood is an open interval, so hindi included yung the next one.
Right, exactly. So Carlo is suggesting that for 1/2, I use my epsilon to be 1/2 minus 1/3. Kasi yung 1/2 minus 1/3, that represents the distance of 1/2 from its nearest neighbor, right? So ito si 1/2, ang pinakamalapit niyang kapitbahay ay si 1/3. So kung yung epsilon na pipiliin ko ay equal dun sa distansya ni 1/2 at saka ni 1/3, ibig sabihin yung open interval na mabubuo ko is something like the one I highlighted here. Malapit, nagpa siya. Pero ito, hindi siya nag-touch dito kay 1/3. Hindi rin siya nag-touch dun sa kanan. Kasi ang pinili niya ay yung difference with the nearest neighbor or with the nearer neighbor. Okay? So that's the idea. So pag kinuha kong epsilon si 1/2 minus 1/3, ibig sabihin yung open ball centered at that at 1/2 with that radius epsilon will not contain any other element of A aside from 1/2. So that proves that 1/2 is an isolated point. And I think now you can guess that for 1/3, I can choose epsilon to be 1/3 minus 1/4. Kasi pag pinili kong epsilon ay si 1/3 minus 1/4, ibig sabihin yung neighborhood, yung epsilon neighborhood will look like this. Or actually masyadong makapal yung marker ko. Pero I hope you get the idea. Hanggang dito lang siya. Dun sa 1/4 not included. Okay? So I hope that's clear to everyone kung ano yung sinuggest na strategy ni Carlo on how to pick that epsilon. Oh, Carlo, do you have a question? Naka-raise hand ka pa?
Okay. I just lowered it.
Okay, yeah, thank you. So great. Just put on the chat, Carlo, that I gave you 1 point. Or di pa sa'yo nag-appear yung chat, no?
Yes, sir.
Sige, note ko na lang dito, Carlo. Para dito ko na lang titingnan. Alright. Okay. Alright, so that's the idea. And actually, that is what is written on the lecture notes, okay? So kung paano nila pinrove na lahat ng points dun sa set A ay isolated. So they took an arbitrary element of the set A, kasi ang claim ay every element of A is an isolated point. So they took an arbitrary element of A, and it's 1/n, and they took epsilon to be 1/2 minus 1/n plus 1. So basically, the point itself minus the next element, or actually the nearest element of A to it. Kinuha nila yung pinakamalapit, they computed the distance between the two, and that makes the choice of the epsilon neighborhood to not contain any other element of A. Kasi nangyari lang, kapag ka ito yung epsilon, ang laman lang nung intersection na to is 1/n. Kasi hindi niya mahagip yung nearest neighbor na 1/n plus 1. Okay. So that that is sufficient to conclude that 1 over n, which is an arbitrary element of A, is an isolated point, thus making all points in A an isolated point. All right? However, kahit isolated yan, um, wala. So, ibig sabihin, hindi sila mga limit points. Okay? But that doesn't make A devoid of limit points. So, hindi ibig sabihin na dahil isolated lahat ng elements niya, wala na siyang limit point. Kasi remember, ang pagiging limit point ay walang requirement na dapat nandun ka sa set na yon. In fact, this set has one limit point, namely 0. Okay, because every epsilon neighborhood centered at 0, no matter how small that epsilon neighborhood is, will have elements of A. Because if you will plot the elements of A, kung halimbawa ito si 0, okay, pag kinontinue natin yung pagpa-plot ng mga elements ni capital A, we'll have a point here, we'll have a point here, a point here, point there. And as n increases, they will be closer and closer to 0. Okay? So, ibig sabihin, kahit gano'n pa kaliit yung epsilon na piliin ko, that the epsilon neighborhood formed by that specific epsilon will always contain elements of A, aside from 0. But of course, 0 is not an element of A, so it doesn't matter if that intersects at 0. Okay? Ang ibig sabihin lang, magkukumpulan yung mga elements ni A around 0 in the long run. And actually, this is a nice springboard to the first topic of Unit 2, which is limit of a sequence. But we'll talk about that more in details, specifically the choice of epsilon. Okay? The choice of epsilon or the choice of n. Depende kung paano natin i-define yung limits ng sequence. Okay? But essentially, yeah, that's an illustration here. Okay, going back, let's go to example 5. I made some correction to example 5, so kindly take note of these. So in example 5, we considered the closed interval AB, and then we want to show that every element of this set is a limit point. Okay, kung yung example 4, lahat ng elements niya ay isolated, baliktad naman, lahat ng elements ng set na to, which is the closed interval AB, is a limit point. And we can prove it by looking at two cases. Okay, the first case is we consider X to be an element of the open interval AB. So ibig sabihin, nasa loob siya nasa interior siya nung closed interval. And then note that if I choose any epsilon, however small it is, the epsilon neighborhood around X, again, X is given to be in the interior of the closed interval AB, which happens to be the open interval AB, then it will contain points of the closed interval AB. Okay, I hope you agree with that. Hindi naman siya mahirap makita via illustration. So, ito yung set AB. Kumuha daw ako ng element X na nandun sa interior nung closed interval. So basta element siya ng open interval. It's easy to imagine na kahit ano pang epsilon yung piliin ko, laging yung epsilon neighborhood na yan, however small it is, will contain elements of the closed interval AB other than X. All right? So that means X is a limit point. So every interior point or any element of the open interval AB is a limit point of the closed interval AB. Now, similarly, if we look at the boundary, say we look at the boundary, if we look at the boundary A, what happens if I draw a very, very small epsilon neighborhood around A? Well, if I draw a small epsilon neighborhood around A, eto, okay? This epsilon neighborhood, pala kita. This epsilon neighborhood is guaranteed to contain other elements of the closed interval AB aside from A. Kasi pag nag-drawing ka ng epsilon neighborhood, automatic na kailangan mong kumuha ng elements mula sa kanan ni A. And you need to do that however small the epsilon is, laging may mahagip ka na elements ng closed interval. Kasi nagmo-move ka pa kanan para mabuo yung epsilon neighborhood. So you see that any epsilon neighborhood around little a has elements of the closed interval AB aside from A itself, right? So you can get elements of A that are very, very close to A coming from the right. And the same thing happens, or the same thing will happen if you look at the element B. So kay B rin, kapag ka kumuha ka ng napakaliit na epsilon neighborhood around B, lagi pa rin magko-contain siya ng mga elements ng closed interval AB. Because in order to form an epsilon neighborhood, you need to move a little bit to the left of B. And once you move to the left of B, however small steps you take, lagi pa rin siyang, lagi kang may mahagip na elements ni closed interval AB. So that makes the closed interval AB, or all elements of the closed interval AB, a limit point. Okay? And we will see later, this has implications why ang tawag natin sa closed interval ay closed interval. Okay? Now, moving on, example 6. Another example is the set of rational numbers. Here, the set of real numbers is the set of all limit points of Q. Pag kinolekta daw natin, lahat ng limit points ni Q, makukuha natin ay set of real numbers. Remember, para maging limit point, hindi kailangan nandun ka sa loob ng set. So ang hinahanap natin dito, ano yung mga limit points ng set Q, ng set of rationals. So meaning, saang mga numbers nagkukumpulan yung mga rational numbers. Okay? Now, the idea here is, ang claim ng example is, yun ay set of all real numbers. Lahat ng real numbers ay accumulation points ni Q. Well, why is that the case? Well, so kung meron kang real number y in R, okay, and we want to show that any open ball or any epsilon neighborhood centered at y will have an element of Q other than possibly y. Okay? Pero si y wala tayong restriction, basta real number siya. So let y be an element of the set of real numbers, and epsilon be any given positive number. And you want to show that B, the open ball. So you want to consider the open, the epsilon neighborhood around y. Okay. But remember, sa topology in R, ang epsilon neighborhood lang ay open interval y minus epsilon, comma y plus epsilon. Okay. Now, what can we say about y minus epsilon and y plus epsilon? Well, y is a real number. Epsilon is another real number. Okay. In particular, it's a positive real number, but it doesn't matter. Y minus epsilon and y plus epsilon are again real numbers. Tama? And then remember the density property of Q in R. So sabi ng density property, which I think we proved last time, sa pagitan ng dalawang real number, laging meron kang makikitang nakasingit na rational number. And we can apply that property here kahit ano pa si epsilon. Si y minus epsilon at si y plus epsilon ay real numbers. So ibig sabihin sa pagitan nila, merong nakatago na isang real number. Okay? Now, that na rational number. Pero may konting butas pala yung reasoning na yun. No? So, posible daw na si y pala yung maging real number. Okay? Pero sabi sa definition ng pagiging limit point, dapat meron siyang ibang elements aside from y. Hindi pwedeng si y yung maging intersection ng open ng epsilon neighborhood at saka ng set. Okay? So, pwede ko palang sabihin, okay, so kung magkakaroon ng butas yung proof pag sinabi yung there exists a rational number between y minus epsilon and y plus epsilon, ang butas dun sa statement na yun, what if y is the only real number between y minus epsilon and y plus epsilon? So that won't qualify y to be a limit point kasi dapat there is an element other than y. Okay? So I need to be careful with the wording of my arguments here. So even though the epsilon neighborhood around y takes this form, maybe I can just consider one subset of it, which is y minus epsilon until y. And then dito ko pala dapat i-apply yung density property. Y minus epsilon and y are both real numbers, so that means there is at least one rational number between these two guys. So meron ditong nakatago na isang rational number. Okay? So dahil may isang rational number dito, let's call that rational number little q. So that means little q is a number, is a rational number that is not equal to y, that is also in this epsilon neighborhood. And again, I don't have any restriction on epsilon aside from being greater than 0. And I don't have any restriction on y aside from being a real number. So that means nag-work to sa kahit anong epsilon, tapos nag-work din to sa kahit anong y. Ibig sabihin, kahit anong y na real number, lagi siyang magiging limit point ng set of all rational numbers. Okay? Does that make sense? Kinakabahan ako kasi walang nagre-react. Okay? Or masyado siyang madali. Pinapahirap ko lang or pinapahaba ko yung discussion. Just let me know because I have that tendency. Lalo na kung hindi ako kumbinsido na naiintindihan ng mga estudyante ko yung mga pinagsasabi ko. May tendency ako na magpaulit-ulit. So please let me know. Lalo na ngayon, wala akong clue kasi hindi ko nakikita yung faces nyo or yung facial expressions nyo. But I hope everything is making sense. Okay. All right. Now, nakakita tayo ng dalawang sets na, or actually dalawang examples. The first example is that there is a set whose limit points are all in the set or all of its elements are limit points. Tapos sa example 6, meron tayong isang set na mas malaki sa sarili niya yung set of all limit points. Okay? Now, let's characterize this a little further and complete the topology on R, or our definition of the topology on R. So let's look at definition 11, which tries to define what closed sets are. Okay? So a set F is closed if it contains all of its limit points. So kapag kalaman niya lahat ng limit points niya, ibig sabihin siya ay isang closed set. Okay? Now, let's adopt a notation para lang mapadali yung pagsusulat natin. Let's denote this by this symbol. Okay. Subset pero may yung bar ay nandun sa taas. If you see me writing this, that means F is a closed subset of R or F is a closed set. Okay? So parang subset tapos may bar sa taas. Okay? So true enough, the previous two examples give rise to nice examples for closed sets. In example 7, we formalize here in a statement that the closed interval AB is a closed set. And that is precisely why we call AB a closed interval. Kasi isa siyang closed set because as we have remarked earlier, it contains all of its limit points. However, the set of rational numbers is not a closed set. Kasi meron siyang mga limit points na hindi rational number. As we have proven earlier, lahat pala ng real numbers ay limit points ni Q. So, ibig sabihin, square root of 2 is a limit point of Q, but square root of 2 doesn't belong to Q, right? So that makes Q not a closed set, right? And then there is a significance, or there is a nice implication if a set contains all of its limit points. And for that, we will look at that set. Basically, paano nagiging kompleto yung isang set. So we will think of completeness of a set if it contains all of its limit points. Actually, you can think of it as an alternative version of completeness. Kapag kalaman, complete ang isang ordered field, kapag kalaman niya lahat ng kanyang limit points, which is basically equivalent to the LUB property. But for us, this is a consequence of completeness. So basically, gusto nating kolektahin lahat ng limit points ng isang set A. And we will see in later discussions why that has nice implications. So in order to formalize that, dahil hindi naman nako-contain ng isang set lahat ng limit points niya, let's define another set. that contains all of the limit points of a given set. And that is what we call the closure of a certain set. And that is formalized in definition 12. In this definition, we consider a set A that is a subset of R. And medyo gusto kong baguhin yung notation. So let's change the notation here. Instead of simply calling it as L, let's replace this by A prime. Okay. So given a set A, subset of R, A prime is the set, be the set of all limit points of A. So yung A prime, siya yung lahat ng limit points ni capital A. So we call A prime, so maybe I will put as a remark later, A prime is called the derived set. Okay. So pagka kinolekta natin lahat ng limit points ni A, what we will get is the derived set of A, denoted by A prime. Kaya ang notation niya ay A prime kasi ang tawag sa kanya ay derived set. So parang derivative, remember derivative, we use primes para ma-denote sila. So kaya yun yung symbol, A prime. Now, the closure of A, denoted by A bar, ay yung union ni A at saka ng derived set niya. So basically here, A bar is A union A prime. Okay? The union of A itself and all of its limit points. So parang pwede nyo tingnan si A bar, yung quote, completion, unquote, ni A. Kasi isinasama natin kay A lahat ng limit points niya. Okay? So some examples in example 8, and actually these examples are nice because they build up on the previous examples that we have considered. So remember set A kanina, consisting of all elements of the form or all numbers of the form 1 over n, where n is a natural number. The closure of A is A union 0. Kasi alam natin, isa lang yung limit point ni A. Ang limit point lang ni A ay 0. So the closure of A is A union set containing 0. And we call the set containing 0 to be the derived set of set A. Kasi yun lang yung limit point niya. Okay? On the other hand, we have seen in example 6 na the set of real numbers is the set of all limit points of Q. So ibig sabihin, Q prime is equal to set R, right? The derived set of Q is R. And then the closure of Q, Q bar, I Q union Q prime. But Q prime is R, so Q bar is Q union R, and that will give us the set of real numbers. So ang closure o completion ni Q ay set of all real numbers. Though I'm using the term completeness here, completion here in a very loose way. Okay. Hindi natin kasi finormalize na ganun yung construction ng completeness. Okay? Pero in some world, in some parallel universe or some parallel Math 155 course, posibleng ganun yung pagkakadesign ng completeness. Okay? All right. Now, for number 3, the set A is the open interval AB. So, kunin natin yung derived set ni A. Remember, ang derived set ni A, set of all limit points. And I guess it's easy to see na ito ay lahat ng nasa loob ni AB. Okay? Kasi lahat ng nasa, strictly nasa pagitan ni AB, ni A and B, are limit points of the open interval AB. Tapos si A at saka si B ay limit points din ng open interval AB. So the derived set of A is the closed interval AB. And if you take A, if we want to find A bar, then this is open interval AB, which is A, union the derived set, which is the closed interval AB. So that will give us the closed interval AB. Okay. And then number 4, if A is a closed interval, pero na-remark na natin in example 6 na ang lahat ng limit points ng closed interval ay nandun sa closed interval. So that makes the closure of A equal to A bar. And again, this is another way to reason it out is that we have mentioned in example 7 that the closed interval is a closed set, meaning the closed interval AB contains all of its limit points. So therefore, the closure of any closed interval is itself. Kasi wala ka nang kailangang idagdag sa kanya. Okay? Another nice example is R bar. If you want to find R bar, this would be the set R union R. So it is basically just the set of real numbers, because the set of all real numbers contains all of its limit points. All right. Any questions so far? Wala naman. Walang magre-react. Okay. Now let's try to prove some nice properties about the closure of a set. Theorem 13. For any subset A of R, the closure A bar is a closed set, and it is the smallest closed set containing A. So Theorem 13 has two claims. Number one, yung closure ni A ay isang closed set. And then the other one is that this is the smallest closed set containing capital A. So let's try to prove it here. Kopyahin natin yung theorem. Okay, now let's start with the first statement. Okay, for the first part, we want to show that A bar is a closed set. Okay, so it's a closed subset of R. Tapos siguro ngayon magigets niyo na kung bakit ito yung preferred notation ko sa closed set. Kasi para siyang closure, meron siyang bar sa ibabaw. And yung paglalagay ng bar sa ibabaw means taking the closure, meaning parang ginagawa nating closed set, yung isang set that is not necessarily closed. Okay? Now, how do we show that A bar is a closed set? So we want to show that A bar contains all of its limit points. So that means we want to show that A bar contains all of its limit points. Okay, so that means if I take an arbitrary element of or an arbitrary limit point of A bar, dapat yung element na yon ay nasa loob ni A bar para masabi na close siya. Lahat ng limit points dapat ni A bar ay na kay A bar. Yun yung requirement sa pagiging closed. So what I'll do is inspect what is the property that is possessed by all of the limit points of A bar, and will that be enough to show that that is an element of A, or that's an element of A bar? So let's try to do that. So I will let Z be a limit point of A bar. And let's see, ano kaya yung pwede kong makuha out of it? Ano yung mga properties ng limit points ni A bar? Well, if it is a limit point, luckily we have limited information about limit points. Parang definition pa nga lang yung alam natin about limit points. So here I know that then kung limit point siya, then for every epsilon greater than 0, there exists an X that is an element of the intersection of an epsilon neighborhood of Z and A bar that is not equal to Z, right? Maybe para complete sentence na yun. And then for all epsilon greater than 0, right? So dahil si Z ay limit point ni A bar, ibig sabihin, pag kumuha ako ng kahit anong epsilon, however small it is, I can always find an element X that is different from Z, that is an element of the intersection of the neighborhood around the limit point and the given set. Okay? Again, definition lang to ng pagiging limit point ni A bar. Okay? Tapos, gagamitin ko yung definition ng closure. Ano yung definition ng closure? Yung closure ay A union derived set. Okay? So that means X is an element of the epsilon neighborhood intersection this set A union A prime. Okay? But this set is, or I can expand this set using, tama nga ba? De Morgan's law nga ba ang tawag dito? I-distribute ko yung hindi pala De Morgan's. I-distribute ko yung intersection over a union. So this would be this intersection A, union, intersection, oops, nawala yung Z. Okay? So if what we know now is that X either belongs to this intersection or to this intersection. And I want to see what will happen kung ganito yung mga mangyayari. So since this is a union, pwedeng mangyari ang isa sa kanila. We don't know which one of these two sets contain the element X. Right? So kailangan tingnan ano yung mangyayari sa bawat posibleng case. So case 1 is if X is an element of the first intersection. Kung dito nanggagaling si X, anong ibig sabihin nito? Kung si X, alam ko si X ay iba kay Z. Pero si X ay nasa intersection ng epsilon neighborhood ni Z at saka ni A. So what can I infer from this statement? Anyone? Plus 1 ulit to sa problem set. Doesn't this statement or phrase look familiar? Oh yes, Dan.
Sir, does it follow po ba na X is in A?
Yes, X is in A. But what about it kung naka A siya? Actually, huwag ka doon mag-focus. Mag-focus ka dito. Anong ibig sabihin ng element siya ng intersection na yan? Doesn't this intersection ring any bell? Ano yung implication nito? Aside from X being in A. You can try again, Dan, kung may maiisip kang idea. Pwede nating i-probe yan. Or anyone else? If you cannot open your microphones, you can type it in the chat box. Baka nahiya lang kayong magsalita. Anong ibig sabihin kapag ka nakakita ako ng X na iba kay Z na element ng intersection na to? Okay, Mary is correct. Limit point ng correct, under a correct track pala. Pero can you further clarify that limit point ng ano? Sino ang limit point ng ano? Para makuha mo yung 1 point. Yes, come again. Sino yung sino yung limit point nino? X po is a limit point ng Z. Try again. Nagiging ang so meron kang number, dapat limit point siya ng set. Right? So dapat blank is a limit point of blank. Yung pangalawang blank dapat set. Tapos try again. Sino yung limit point ng anong set? Ayan, malapit na. Come on, guys. Huwag niyong baliwalain yung plus 1 sa problem set. Ang problem set natin usually up to 50 lang. So, ibig sabihin, ang isang tamang sagot per lecture is about 2% na. So, okay, may gusto pa bang humula? Humula talaga eh. Five, four, three. Okay, I guess Mary got it right. Thank you. So Z is a limit point ni A. Tama. Kasi di ba, so sulat ko muna para ma-analyze natin. Then Z is a limit point of A. So remember, ang definition ng limit point, ang isang number ay limit point ng isang set. Kapag merong epsilon neighborhood around that number that intersects the set in an element other than the number itself. So we see here that yung yung epsilon neighborhood centered at Z, intersection the set A ay may lamang isang element, tinawag ko siyang X, pero ang alam ko si X ay iba mula kay Z. So that makes Z a limit point of A. So be careful. Nice try, Denmark. Nice try. Though we need to be very particular about it. Yung nasasabi natin na limit point, siya yung center ng epsilon neighborhood. So Z is an element of is a limit point of A because we found an element different from Z, namely X, that belongs to the intersection of the epsilon neighborhood and the set A. Okay. Okay, now, Mari, you got the plus 1 point for the problem set. Okay, now, ano kaya yung susunod kong argument sa proof? So, ibig sabihin, kung siya ay element, kung si Z ay isang limit point, so that makes Z an element, para kompleto, that is, Z is an element of A prime. Tama? Dahil element siya ng A prime, thus, si Z dapat ay element ng A bar. Kasi si A bar, yung closure ni A, ay A union A prime. And nandun siya sa A prime. So si Z dapat na kay A bar din. So if the first case is true, then we are sure that Z is in A bar. So nako-contain siya, nako-contain yung limit point na Z doon kay A bar. Okay? But there's a second case, another possibility. Case 2 is if X is an element of the intersection of the epsilon neighborhood and A prime. So what does this tell us? Okay. So again, my goal is to show that Z is in A bar. Okay. So ang alam ko ngayon, or madali na ba ito? Kasi napakita ko dito si X ay element ni A bar. Gusto ko ipakita si Z ay na kay A bar. How can I show that Z is an element of A bar given only that there exists an X other than Z that is in the intersection of the epsilon neighborhood and A prime? Okay, let's see. If I will only apply the definition of intersection, then I will get X is an element of A prime. Pero hindi naman ako interested kung saan nagbe-belong si X. Interested lang ako kay Z. Gusto kong maipakita si Z ay na kay A bar. Okay? And usually, the way to do it is to show that Z is a limit point of A. Tama? Pero paano ko siya mapapakita dito? Kasi pag napakita ko na si Z ay limit point ni A, ibig sabihin si Z ay na kay A prime, So therefore, dahil si A prime ay subset ni A bar, so dapat si Z ay naka A bar din. Pero this statement only tells us that X belongs to A prime, but I'm not sure if Z belongs to A prime. Okay, nakikita nyo ba yung kung bakit mas mahirap yung case 2? Or at least naisip ko mas mahirap siya kaysa kay case 1. Unless I'm missing something obvious here. Okay? Kapag ka na-stuck kayo, like what I am experiencing right now, let's try to look at an illustration. Okay? Now, oops. Okay. Halimbawa, ito si A bar. Halimbawa, ito si A. Tapos halimbawa, ito yung A bar. Okay? Tapos nandito kunwari si Z. Okay? Make generic illustrations. Okay? Kasi si A dapat mas si A bar dapat mas malaki kay A. So A bar pala to dapat. Okay? Kino-contain niya lahat ng limit point, so mas malaki siya dapat kay A. Kasi A union A prime siya. So si Z kunwari nasa labas. Pero ang alam ko, kahit anong epsilon neighborhood centered at Z, may laman na element ni A prime. Okay? So ibig sabihin, kapag kinuha ko tong kahit anong epsilon neighborhood, for instance, if I take this epsilon neighborhood, lakayan ko ng konti. Kunin ko tong epsilon neighborhood na to. Starting here until here. Okay, that's my epsilon. Okay. Meron ako ditong makukuhang element X dun sa intersection na yon. Kasi we said in the assumptions for case number 2, there is an element X that is in the intersection of the epsilon neighborhood and A prime. Okay. Si A ay etong set na to. Si A bar yung malaking set na to. So in the worst case, si A prime ay yung nandito sa pagitan. Kunwari wala siya kay A. That's just a generic scenario. Okay? Pero pwede rin siyang nandun sa loob ni A. Pero okay, but what do we know about X? So here we know that X is in A prime. Okay. Kasi nga by definition ng intersection, si X ay nasa nasa epsilon neighborhood ni Z at saka si A prime ay nasa epsilon neighborhood nasa A prime, nasa derived set ni A. Okay. Now, I want to show, or my claim is Z is also in A prime. I want to show na si A prime ay element din, si Z ay element din ni A prime. Isa rin siyang limit point ni set A. So, ibig sabihin, kailangan kong humanap ng element ng intersection na to. So, that means I need to find an element of this. Tawagin ko siyang epsilon star. Iba siya dun sa kanina, kay X. Centered at Z. Pero gusto ko ngayon ang ka-intersection niya na lamang ay si A. Kailangan makahanap ako ng epsilon star. Okay? Or kailangan ko ma-prove na kahit sa anong epsilon star, lagi ako may makikitang element niya. But what could that element possibly be? Okay, so here we can take advantage of this statement. X is an element of A prime. Ibig sabihin, dahil si X ay element ni A prime, that means for every epsilon, maybe we can call it for every epsilon tilde. Naubusan na ako ng symbol. For every epsilon tilde greater than 0, there exists a x tilde that is an element of this set. Okay. Kasi si x ay limit point ni A prime. Okay? Ay limit point ni A rather. So ibig sabihin kahit ano pang epsilon tilde greater than 0, yung open ball or yung epsilon neighborhood centered at x intersection A ay laging may isang laman na x tilde na kakaiba mula kay x. Definition of limit point. So ibig sabihin dito ay merong epsilon tilde. So pag pumili ako dito ng maliit na epsilon, ibahin ko yung kulay. Gawin natin blue. Pag kumuha ko dito ng maliit na epsilon tilde, epsilon tilde, alright? Meron dong laman na x tilde na element ni A. Mali nga lang yung drawing. So dapat yung boundary kay A ay nandito. Should be somewhere here. Kasi daw dapat kahit anong epsilon neighborhood around x dapat magkaroon ng element aside from ng element ni A aside from x itself. So para magkaroon ng x tilde. So si x tilde nandito sa pagitan nito. Nasa pagitan ni Z at saka nasa pagitan ni x. Right? So that means by this illustration, I will let you try to formalize that. I can say that there exists an x tilde element of what? Element of, say, x minus epsilon tilde until x plus epsilon tilde. Okay. Pero this set, okay. Yeah. Pero pwede kong piliin yung, remember si epsilon ay simula dito hanggang dito. Okay? Pero per my illustration, okay, lagi akong may mahanap na epsilon tilde na nagkakaroon ng x tilde na element ni A. Kasi nga si x ay limit point ni A. And I can choose epsilon tilde to be very, very small. So that means, nako-cover siya ng epsilon neighborhood around Z. Kasi malalagay siya somewhere dito. So that means that x tilde will belong to the intersection of the epsilon neighborhood around Z and the set A itself. Kailangan ko lang piliin ng maayos si epsilon tilde. Epsilon tilde could be what? It could be basically, pwede siya yung difference ng distance between Z and the boundary of A minus epsilon. So doon ko siya kukunin, yung intersection na yon na x tilde, doon ko siya kukunin doon sa pagitan ni x, pagitan ni Z plus epsilon at saka nung x minus the distance from the boundary of the set A prime or A bar. Okay. So in other words, or if we will formalize that, we will be able to find or to show that indeed Z is also a limit point of A. So dahil si Z ay limit point din ni A, same conclusion as before. So Z is an element of A bar, then that means, Z is a limit point of A as well. So that means Z must be in A bar. Okay. And then what is our assumption here? Z is a limit point of A bar. And in any of the two cases, which will exhaustively cover all possibilities, si Z ay nagbe-belong kay Z bar. So that means That means A bar contains all of its limit points. Dahil na-contain niya lahat ng limit points niya, si A bar I isang closed set, which takes care of the first half of the thing that we want to prove. Okay? Though my second case pa, or my second claim pa yung theorem, but I guess this is easier than that case. Tuloy natin. Second point is this. So second bullet is we want to show that A bar is the smallest closed set containing A. Okay. And I will prove this by contradiction. So I will suppose there exists a closed set B in R such that A is contained in B, but B is smaller than A bar. So kunwari, hindi si A bar yung smallest closed set na naglalaman kay A. So suppose there is an intermediate set B, okay, na closed din. Now, per this statement, si B ay isang closed set. Kino-contain niya si A, pero merong mga elements si A bar na wala kay B. So maybe we can start with that. So there exists some elements of A bar not in B. Pero ano na lang yung mga candidates na yon? Dahil si A bar ay union ng set A at saka ng limit points ni A, ibig sabihin, ang candidate lang para maging elements ni A bar na wala kay B ay mga limit points ni A. Tama? Kasi kino-contain na ni B lahat ng elements ni A. So ang kulang na lang ay yung mga limit points ni A. So dahil proper subset yung kine-claim ko dito, na mas maliit si set B, ibig sabihin si set B, meron siyang merong elements si A bar na wala kay B. And in particular, those elements can only possibly be some limit points of the set A. So in particular, these are maybe not these are, pero I can say in particular, there exists a limit point, say x, a limit point of A. I denoted that by x element of A prime, such that x is not in B. Alright, clear ba yan? Kung bakit ko na-conclude yan? So merong isang limit point si A na wala kay set B. Kasi otherwise, kung lahat ng limit points ni A ay na kay B, so si B, hindi na siya proper subset ni A bar. And we'll try to draw up a contradiction from this statement. So what can we say here? Si X ay element ni A prime. Dahil si X ay element of A prime, it follows that for any epsilon greater than 0, there exists a y not equal to x, such that y is an element of this intersection. Okay? So dahil sinabi natin si x ay limit point ni A, so ibig sabihin yung intersection ng kahit anong epsilon neighborhood ni x at saka nung set A ay merong isang laman other than the number x. Tinawag kong y yung element ng intersection na yon. Okay? But what do we know about the set A? The set A is a subset of the set B. So kung nasa set A si y, so si y ay nandito at saka nandito rin siya. So kung si y ay na kay A, si A subset ni B, ibig sabihin si Y dapat na kay set B din. Right? Si Y ay na kay set B, si Y ay nandito sa epsilon neighborhood. So we can say that Y is in the intersection of the epsilon neighborhood around X and the set B. Okay, by virtue of A being a subset of B. Pero what does this statement tells us? Sige, +1 ulit. Anong sinasabi sa atin ng statement na yan? Anyone? Oh, wala uling gusto magsagot. Oh, delayed lang yung Microsoft Teams ko. Come on, guys. Wala talaga. Okay, so tingnan natin. So si Y daw ay element ng intersection ng ng epsilon neighborhood at saka ni B. So ibig sabihin, kapag ka nakakita ka ng element ng epsilon neighborhood na different from the center, that also belongs to a set. Ibig sabihin, that makes that this center a limit point of the set. Tama? So here I can conclude that Y is actually a limit point of B. Kasi nakakita tayo ng epsilon or kahit sa anong epsilon neighborhood centered at X. Ang intersection niya with B ay may lamang iba aside from X, namely si set Y. So ibig sabihin, Y is a limit point of B prime. Pero what does that tell us? Alam natin si B ay closed by assumption. We assume that B is a closed set that contains the set A. So dahil si B ay closed set, dapat laman niya lahat ng limit points niya, right? So Y being a limit point of B, that means Y must belong to B because B is closed, right? And that's our contradiction, because here we're saying that Y is in B, but earlier, not Y, this is X. Yung center, yung limit point. So X is an element of B, but here we said X is not in B. Okay? So therefore, dapat wala ng set B na mas maliit kay A bar na closed and contains the set A. So we must accept that A bar is the smallest closed set containing containing A. Imposible makahanap ng closed set sa pagitan ni A at saka ni A bar. Okay? Okay, napahaba yata yung proving session natin doon. Pero I hope things are getting across. At least some tidbits of information are coming across. Mahirap siguro tong makita at one sitting. So pwede niyo siyang balik-balikan, or you can write the proof or follow the proof later. So if you will have time, para ma-practice din kayo para sa mga susunod na problem sets. Okay? Now, it's almost 5:20, but can I borrow 5 more minutes? If you have classes after, or if you have something to do, you can leave and just look at the recording later. I'll just try to squeeze in the rest of the lecture notes in 5 minutes. So if that's okay with you guys. Though yung mga nandito pala ay crucial results din, no? 115, 114. Sige, hindi ko na siya itatry tapusin ngayon. So let me end by just by these examples or some remarks. Now, if a set is not open, it doesn't mean that it is closed. All right. So Hindi ito closed or open. So, kapag ka hindi siya open, hindi necessary na close siya. And also the other way around is also true. Hindi necessary na kung siya ay hindi closed, ibig sabihin ay hindi siya open. Kaya siguro minsan nagtataka kayo bakit parang napaka-specific sa math pagka may define na term. Bawa, a set is disconnected if the following are satisfied. Tapos may susunod na definition. If a set is not disconnected, then it is connected. So kasi napaka-specific ng mga terminology sa math. So hindi usually nag-a-apply yung mga antonyms in English or contradictions in English, right? A classic example is closed and open sets. Pag hindi siya open, hindi ibig sabihin na closed siya. And kung hindi siya closed, hindi ibig sabihin siya ay open. Because remark number 2 tells us that a set can be both open and closed. And remark 3 tells us that a set can neither be closed nor open. So itong half open, half closed interval AB, hindi siya closed at hindi rin siya open. Hindi siya closed kasi hindi niya kino-contain lahat ng limit points niya. Remember, we knew that sa isang open interval, yung boundary ay laging limit point. And that is also true for half open and half closed interval. A is a limit point of this interval, and yet A is not in the set. So that means this interval doesn't contain all of its limit points. For instance, it doesn't contain A, which is one of its limit points. So this guy is not closed. And then hindi rin siya open kasi look at the endpoint B. Si B ay element ng interval, pero pag kumuha ka ng epsilon neighborhood around B, kahit gaano kaliit or kalaki, laging may elements na nasa labas ng interval, right? Kasi di ba ang usapan, para maging open, dapat sa lahat ng elements niya may epsilon neighborhood na properly contained dun sa set. Kay B, pag gumawa ka ng epsilon neighborhood, laging may nakakasama na element na labas dun sa interval. So this is a classic example that of a set that is neither closed nor open. Okay. Now, dun sa example 2, sets na parehong closed at open at the same time, empty set. The empty set is closed kasi kino-contain niya lahat ng limit points niya. Kasi wala naman siyang element, so wala siyang mako-contain na limit points. So by default, wala siyang limit points. And vacuously in logic, that means na-satisfy niya yung definition. Kasi wala naman siyang laman, so walang chance na may ma-miss siya na elements. Kasi by definition, wala siya dapat na laman. And then it is open because kumuha ka ng kahit na anong element niya, merong epsilon neighborhood na nasa laman ni empty set. Pero wala akong element to test, right? Wala siyang laman, so wala akong matetest na element. So vacuously, the empty set is both open and closed. Okay? Now, kung hindi nyo matanggap na si empty set ay both closed and open, but it is vacuously true, set of all real numbers. Okay, it is closed kasi ang limit point ni R ay R itself. Okay, I think we have mentioned it in one of the examples earlier. So nilalaman niya lahat ng limit points niya. And then kumuha ka ng kahit anong real number, kahit anong open interval centered at that real number will be a subset of R. So that makes it open. So yan yung classic example na parehas closed and open. So I guess I will end here. Gusto ko sana matapos yung buong lecture notes, pero di pa. So that's good news for you because may extend na naman yung homework number ano na ba yun due? Homework number 2 dapat, no? Na maybe I'll move homework number 2 to Monday. Oh yes, Carlo.
Sir, question about homework 2 lang. Yung number 2 item, it mentioned maybe sa next lecture kung pwedeng paki-explain further. It mentioned boundary of A. I didn't see any explanation what boundary of A technically means. May idea ako pero
Okay.
I wanted to be clear.
Yeah. Thank you, Carlo. Yeah, I don't know if I sent you the latest version ng Homework 2, yung Homework 2-2. Kasi
Oh.
late ko na-realize na hindi pala dinefine dito sa lecture notes yung boundary. So I needed to include in homework yung definition ng boundary. So maybe I can flash it next meeting and give you some hints on homework 2 as well. And then magdadagdag ako ng definition probably sa end netong lecture notes. So i-define ko anong interior point o anong interior ng isang set, ano ang boundary ng isang set, just to add to our terminologies which we might find helpful in succeeding discussions. So kaya siguro please re-download the lecture notes at least every after unit. Kasi pagka natapos na natin yung lecture notes for unit 1, na-incorporate ko na lahat ng corrections or lahat ng additions na gusto kong idagdag sa kanya. Okay? So, yeah, ganun na lang siguro. Then, yeah, just remind me next time, give you some hints about homework 2. Okay? Para hindi naman kayo in the dark magsasagot. Okay? So, yeah. So, let's extend that. So, ibig sabihin, mamumove din yung homework 3. So, yeah. And it's fine. Hindi naman tayo nagmamadali. I guess it's better to take some time to digest the materials here rather than just go through them for the sake of finishing a module. So yeah. Okay, other questions? Bakit nga ba tayo nagtagal ngayon? Ang tagal ko kasi dun sa proof, no? Pero yun yung gusto ko na spontaneous yung proving para kasama kayo dun sa thinking process. So yeah. Okay, any other questions or concerns? Okay, wala na? Okay, go CK.
Should other values of a set po ba cluster around a point x from both sides to say that x is a limit point? Dapat from both sides po ba?
Hindi naman. So ang requirement lang dapat ay pag pinaliit mo ng pinaliit yung epsilon neighborhood, dapat ay may makukuha kang element ng set pa rin. One example is yung 1 over n natin kanina na set. Remember, si 0 ay nandito, 1, 1/2, 1/3, 1/4. You see, we said that 0 is a limit point or is a cluster point of the set A consisting of 1 over n's. Pero hindi naman nagka-cluster yung points mula sa kaliwa. Kasi wala namang elements mula sa kaliwa ni 0, ni A. So dito lang sila nagka-cluster from one side, but that is enough. Because the only requirement is any epsilon neighborhood around that limit point will contain elements of A other than the limit point itself. So posibleng sa isang side lang sila mag-cluster. Okay,
Salamat po, sir.
Okay. Yeah. Yep. So hindi kailangan both from the left and from the right. So hindi siya katulad ng limits. So siguro doon yung ina-attach yung idea, no? So ang requirement lang nagka-cluster around either from the left, from the right, or both. It doesn't matter. Okay? Any other questions, concerns? Okay, if there are none, then let's call it a day. I hope you guys enjoy the rest of the evening. Thank you for coming today, and let's see each other again on Thursday. Bye, everyone.
Thank you, sir.